Hello everyone, this is your host Hemant Gangwar, and today we are going to understand exactly how we can integrate Terraform with Ansible. These are two different tools and why we want to integrate them. Let's understand with the basic example. You can have a house which you can build and you need the furniture for that. Now the thing is, both the vendors, one who is building the house and the other who is building the furniture, they have the capability to do both the things. But the thing is, we choose the vendor which have the best hands-on experience and providing the stuff. So the same story goes with Terraform and Ansible as well. Both are masters in their field. Terraform, on one hand, deals with the infrastructure provisioning, while Ansible, on the other hand, is majorly into orchestration and configuration management. Terraform starts with its communication with the API-based structure, communicating with the API of the cloud providers, while Ansible, on the other hand, communicates on basis of SSH layer. Then Terraform mainly configures cloud infrastructure like AWS, Azure, etc. While Ansible majorly configures different type of servers like Linux and Windows, etc. Terraform is writing style is a bit of a declarative type that it majorly deals with the initial state and the last state. It's more interested in providing you the final output. While if you speak about Ansible, that is more on of a procedural type of stuff that it used to complete each and every task in a sequence or in an order in order to achieve the final state. But at the end of the day, both are doing their task. So rather than doing a competition, we can combine both the tools and can have a single-handed solution that can handle everything. And for that, Terraform has provided provisioners. If we read the literal definition given by Terraform for provisioners, they can be used to model specific actions on the local machine or on a remote machine in order to prepare servers or other infrastructure objects for a service. If this definition is not making sense, you can simply understand that if you're a Windows person, you can do an analogy with the PowerCLI or PowerShell. If you are a Linux person, just consider it as a simple shell-based commands. For AWS person, it can be compared with the AWS CLI. For Ansible, it is an ad hoc, and for Puppet, it can be a bolt. While Terraform is calling as a provisioner, it is considered as a last resort because this is something which you don't find in the resources. The best practices use the resources to deploy the infrastructure and to do other things. But if you cannot, or if you need some extra hand, you can run some command-based stuff as well with the help of provisioners. I hope this is making sense as of now. Let's understand more on basis of a practical demo. So in order to explain it, I have written a Git code. Let's first download from my Git repository. You can always refer this Git repository at Hemant Gangwar in Terraform Learning. Now moving towards our Linux host so that we can test all that stuff. You simply need to have a Git binary installed in your system and do a Git clone and the repository name. Now it's cloned. Then proceed inside the repository and we have created a section automation for us. Now, just to make things easier and differentiate exactly what variations we can provide, I have written two methods. So let's see them one by one. So go to method one and see the files over there. So this is your key file. Before doing that, let's first initialize the Terraform directory so that you won't have to wait a lot. Okay, so it's done. We basically initialize the plugin on the help of the provider.tf, where we mention exactly which plugins we need to download. Then, again, we have the main file instance.tf. So let's see exactly what is written inside it to understand it more further. It simply consists of a EC2 resource. It's a simple resource definition that will take an AMI ID, an instance type, then in which availability zone you want to deploy your EC2, and a simple key name. If you scroll up, you can see the key is also present over here in order to make sure that my instances can be easily connectable. Then we have a simple tag. Now we proceed towards the provisioner section. Just to understand that the provisioner section is a part of your resource only. So it won't go out of the resource. It will work for this resource only. So it contains of two parts. The one is remote exec, and the second is a local exec. It's wrong to say part. Basically, it's two type of deployment strategies which is follow. The remote exec is more of a local type. The local type to the instance which is deployed. So it is used to deploy the local commands on your EC2 instance. Don't confuse with the name. The remote simply means that is remote to the Terraform machine, not remote to the EC2. So it will be local to your EC2 and will run whatever commands you want to do. For example, I want to set a host name for my EC2 instance. Then it will take some connection strings. Okay, just one thing before that. In both type of provisioners, like in local or in remote, your commands passing is a different method. Where in the local, you can simply pass the command using a command key pair, while in the remote one, you have to use an inline based method and you can give multiple commands. So now proceeding towards the connection part. Here we are defining few of the things like what will be my host name. So my host name will be my AWS instance and the resource type, which is understandable to Terraform, and then a public DNS. So it will connect to the DNS name of the machine. Then the type of the connection type will be SSH base. Then the user which is going to connect, that will be EC2-user. And exactly the private key which we are going to use. This will be the key, that is AWS exam testing.pem that I have made for myself. You can download the private key of your infrastructure into your machine and test accordingly. Then we'll proceed towards the next sections of the local exec. Now the local exec means the commands which are local to my Terraform machine. So what I'm going to do, I'm simply going to first going to fetch the name of the machine, and I'm going to write inside the inventory file, which will work as my Ansible inventory. This I have written so that I don't have to manually update my inventory file. It will be a bit of a dynamic thing. Now my second local executioner provisioner is like, it will install Apache base packages and it will start my web server. In my output section, I have written so that the output IP address of my machine will be provided, the public IP address of my EC2 will be provided, and the public DNS name of the EC2 will be visible. I hope that is clear to you. Now this is the key, this is your instance file, this is the inventory, which can, if it's not clean as of now, let's nullify it to avoid any confusion, and that is a simple Ansible configuration file. It is saying that your inventory file will be any file with the name or directory of the file inventory. Then remote user which is going to connect is EC2-user. Host key checking is false so that we don't have to put yes or no every time. Then my private key file location, it's inside the current directory and the file name is this. And then some privilege based methods, exactly which user is going to connect, which method it's going to perform. So that's in the theory part. Let's do all this in action. So the directory is initialized and let's apply it. So first do a plan to see that everything is correct. Okay, so plan is fine, nothing irrelevant visible to it. Let's perform the actual rollout. So it's first creating the EC2 instance. Then as per a remote exec, it is first trying to communicate with the EC2 name. Now it's taking the dynamic name, which is generated by Amazon for it, and trying to perform further connection. Now it's taking the different key-based parameters, username, password, etc., and will trying to keep on making the connection unless the machine is ready and it's able to connect. Now, once it's able to connect at this point, it is trying to run some local commands, like it's trying to install yum. It is getting some errors at this point, maybe because of some permission issues with the keys or something like that. So let's try to see exactly what is the permission of a key. It's x for me. Let's change the permission so that it's only root readable, and then again perform a deployment. Meantime, the resource is recreated. Let's check a flow diagram exactly how we are dealing with all that stuff. So this is my client machine where Terraform is installed. I'm invoking the Terraform binary, and it's communicating with my cloud-based API. Exactly, it can be AWS, Azure, or anything. So it's first communicating with the cloud API, and on the basis of the resource which we have defined, it will roll out a resource for you. So we called the EC2 resource, so it deployed an EC2 instance for us. Now, once an EC2 instance is deployed, Terraform will invoke the provisioner section. So provisioner, though I have not shown in this diagram, but provisioner can either run some local commands based on the Ansible playbooks you can provide according to your environment standard, and perform the automation or the configuration management on EC2, or it can also run some remote commands directly on the EC2 in order to achieve some of the stuff required. Now back to our machine, we can see it's still trying to communicate. The machine is created, but Terraform is still trying to perform a remote connection. So now I can see at this point it is able to connect, and with the help of the local exec and with our Ansible stuff, it's trying to communicate and deploy the perform the actual configuration management. Here I have used an ad hoc based command. You can run your playbook. So it will take the time depending on how much time the yum command will take to run to complete the stuff. So if we scroll up, it has successfully installed the yum package and started the Apache web server for us. So how we want to test that, if it is working or not, pick this dynamic name or the IP of the machine and go to your browser and just paste it over here. Some default web page of Red Hat should be present. Yes. Now if you put some stuff inside the web.html, the things will be more clear to you. So just go back and let's try to communicate with the name. Okay, we are inside the machine, and let's try to write some of the stuff. Sorry, my bad. Index.html. Okay, so one thing we can see that my EC2 name is also renamed from inside, and let's go again on our web browser to see. Yes, the changes are visible. So my web server is working fine as of now. This is one form of the strategy which we performed. Now exit the machine and move to method 2. See what's hidden over there for us. So for this, I'm using some of my, if you viewed my previous videos, I use the user data thing provided by EC2. So in this strategy, I use that thing as well. So first do a Terraform init. So this directory is also initialized based on the plugins present in the providers.tf. Now start looking at the actual Terraform code. So this section also contains instances TF where we are again going to deploy an AWS EC2 resource with the AMI instance ID, zone, and the key file. This time we are providing user data through the file base, this function basically, and the file is install command.sh. We will have a look in that as well in a few minutes. And this is the name of my EC2 machines. Now proceeding towards the provisioner section. This time we have not used the remote section, but instead only local section. So what this local execution is doing on the local Terraform machine, first it's fetching the details of your EC2 machine and put it inside the dynamic inventory. Then this section is just fail safe because in few occasions I noticed that the machine is created by Terraform, but still it is not accessible. So the code fails. So just giving an additional sleep, we can change the sleep to less value as well. Even if you skip that part, that hardly make any difference. And after that, we will use again our Ansible code to do the required configuration management. The thing that the initial remote exit, which this time we are dealing with, we are handling with the help of the user base, user data. So let's see exactly what is inside the install.sh, install command.sh. So now this time it's in a pre-prep, it's trying to first create initial environment for us. So it's creating a user first, providing the sudo access to that user, then creating the directory stuff, then necessary ownership for that directory, then file, and this is my simple key of my machine, which is going to communicate. In my case, my same machine is acting as the Terraform as well as Ansible node. So the authorized keys of this, not authorized, the RSA keys of my same machine will be copied inside that. So the same key that are copied inside so that I can communicate easily on my host, then setting the required ownership and permission on my keys. So this thing is handled by the user data stuff of EC2. That's all. Just nullify it one more time to just avoid any confusion. Then let's see how the ansible.cfg file is changed over here. Like previous occasion, it's again looking into the inventory file or directory. The remote user this time, we are not going to use the EC2-user, rather than we're going to use the user which we have created as Ansible test, and the host key checking is false. Since we already copied the key on the EC2, we do not need the password or any other private key of that. So that's all the theory part. Let's rock and roll. Just one more thing before that. I don't want again the same errors, so let's say for do a Terraform plan first and see if we are receiving any errors. It's fine. Now let's performing the actual deployment. So we can see that firstly, my host name fetching inside the inventory is performed by the local exec. Then simple fail-safe sleep command. So it may wait for these many seconds. For that time, I'm pausing the video. So it's just going to end sleep cycle and then going to perform the next command. So now it's proceeding with the Ansible thing. So based on the user data which we have created previously, that is fine. All of our communication should be good and the EC2 should be deployed with the correct things. In case any of your permissions or ownerships are wrong while providing the previous data, it will fail and you might get some extra errors. So looking on the logs, it looked like Ansible is able to communicate properly and able to deploy the things for us. And just have a look on the new machine now. Am I able to communicate with it with a different user? Yes, I'm able to. And it's retaining its names as I have not provided any name-based command over here. So that's fine for me. Let's see on the browser level as well, whether it's able to provide the web page, default web page. Yes, it's able to provide the default web page as well. So that's all from my end on this provisioner thing. Do read this thing. I'll add this page link as well in the note section so that you can have a deeper look. Share with your friends and do let me know exactly about your feedbacks if you want any improvements or how the things are for you. Thank you very much. Have a nice day.